So 126, right? 126. Common Core standard is geometry. Okay. And we're going to do, C, because it's going to be so it's to know precise definitions for circles and area. Okay. I guess perimeter as well. Perimeter. Okay. So what makes this so different from what you learned in 6th grade is the fact that we are going to apply some algebra. It's not that difficult. It's just we're going to go ahead and look at things in terms of m. So when we look at example 1, the answer I'm going to get is an answer in terms of m. Does that make sense? Because I don't have really numbers. So if I want the area of this thing, the area is just going to be its length, which is my 5m plus 3, times its width, which is m. And of course I can just distribute there, so area would be a 5m squared plus a 3m. That's it. That's all there is to it. We don't have an answer as far as like a numerical answer. It's just in terms of m, because that's the problem, okay? Perimeter, to do perimeter, we're going to add all the way around. So let's make this top side of the rectangle a 5m plus 3. We'll make this side here just an m. So if I want to do perimeter, I'm just going to add it all the way around. I'm going to go 2 times my 5m plus 3, because there's 2 of those, plus the 2 m's, because there's 2 of those, right? So if I add up all the way around, I'm going to have this plus this, so I've got 2 of those, and then this plus this, there's 2 of those, right? If I simplify that, I'm going to have a 10m plus 6 plus a 2m, right? 10m plus 6. And then if I simplify or combine the 10m with 2m, I'm going to end up with a 12m plus 6 for my perimeter of the rectangle. Okay? Not bad. Thumbs up. Easy. Okay. Yep. Don't worry. I'm going to ignore my phone because I can't use our phones in class, can we? All right. Number 1. Let's take a look at the second example, which is the triangle. Let's do perimeter first, because perimeter is actually not too bad. We'll do perimeter. To do perimeter on this thing, I'm just going to add up all the sides. So I'll go 3y plus 7y plus 8 plus a 3y plus 12, okay? And again, my answer is going to be in terms of y. It's not going to be a numerical answer. So I got 3 and 7 makes 10 of a 13y plus 8 and 12 makes 20. That is the perimeter. And again, it's in terms of y. Now the area, base times height divided by 2, or it's just as easy to go 1/2. So the area, 1/2 base times height, 1/2. Let me do the height first because I see the 2y. 1/2 height times base. I'll stop for a second. Let you think about what I did. Okay. So instead of going base times height, I went height times base. Anybody see why I would want to do that? Why did I want to put that number first? Hopefully you see why I wrote that number first. Come on, anybody. Why did I put the 2y right there?
Because you have to multiply. You have to divide.
Yeah, I'm going to take half of that, right? I can take half of 2. Can you take half of 2? Heck yeah. What's half of 2? 1, right? So that'd be a 1y times a 7y plus 8, right? Get a 1y there. I don't need the 1, but I took half of the 2. And then if I distribute, I'll get a 7y squared plus an 8y. And that's going to be my area. Okay, easy? All right. Okay, example 2, we're going to go back to 6th grade math. No problem, we can handle this. Now, what I want, though, in example 2, I like things in terms of pi. My oldest son's traveling to, where's he traveling today? He's been traveling all over the place. I think he's traveling to Delaware today. Anyway, moving on. So that's probably my son. So, circumference. Let's do circumference first. Okay, the thing about circumference, I've got 2 formulas, right? And one formula was diameter times pi, or we could do 2 times the radius. But I see the diameter. Let's use diameter times pi instead of the 2r pi, because I've got the diameter. So the circumference of the circle is easy. It's just going to be 18 pi inches. That's it. Leave it in terms of pi. All right. Mathematically, we like things in terms of pi because that's the exact answer. Otherwise, we'd get a decimal answer, right? If you were to go into the hardware store, though, you'd probably have to change it. I mean, you know, they'd think you're crazy if you said, I want a board 18 pi inches. They'd kind of look at you like you've got horns or something. Area, we're going to need the radius, but the radius is easy. That's just 9, right? So the area is going to be pi r squared. So our area is going to be pi times 9 squared, right? That's an 81. So 81 pi inches squared. And let's leave things in terms of pi, okay? Leave things in terms of pi if you can. If you really need to go ahead and, you know, get a decimal answer, you can. You can go, okay, what's 81 pi? And you get a 254.469 blah, 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 blah. But isn't that a better answer? Looks nicer too, doesn't it? Okay, that's a better answer. Okay, number 2. Okay, so let's do first of all, and that's in terms of x. Our answer will not be numerical. It's going to be in terms of x. So that's easy. Our circumference is going to be, I'm going to have to go probably 2 pi r, and the r is my 2x plus 1, right? I got a 2 pi r there. So our circumference is going to be, let's see, it's going to be a 4x plus 2 parentheses pi, okay? I'll show you, I got a 4x plus 2 times the pi, okay? So just left the pi on the outside. You have to have the parentheses though, because both of these are multiplied times the pi, right? You've got to have the parentheses, because both of them are multiplied times pi, okay? Area, circle that answer. Yeah. I said 4 and I wrote 2, didn't I? I said 4 and I wrote 2. Thanks, Katie. I just hate it when I make mistakes. And live on film, so now I'm caught, right? All right, area. Pi r squared. So the area is, thanks, Katie, pi times a 2x plus 1 squared. And we'll just leave that answer. That's a good enough answer. We can multiply that out, but it's a nicer answer just like that. I just squared that, that's all. 2x plus 1, quantity squared. I have to have the parentheses, right? Because I need to show the whole thing, the entire thing is squared, okay? Thumbs up. Easy. Thumbs sideways. Where you at? Okay, good. Lots of thumbs up. Okay, example 3. Now, example 3, the area of the circle is 49 pi, okay? So let's be smart. If that's the case, think it through. Think it through. What's the radius of this circle? What's the radius of the circle? How did we get the 49? How'd you get a 49? Yeah, it's 7 squared, isn't it? So the radius has to be 7. Does that make sense, everybody? It's just going to be the square root of the 49. So let's find the radius. We've got the radius, which is the square root of 49 is the radius. And then now to find the circumference. The circumference is just simply 2 pi r, which is 2 pi times 7. 2 times 7, 14. So my answer is a 14 pi. Do I have a unit? I don't have a unit. So it should be inches or centimeters or something, okay? Pretty easy? All right. Now, you ready to turn the page? So let's turn the page. All right. So we have these formulas, and I want to do these. I want to use both these formulas, okay? And then I'm going to show you an easier way. You have to know the formulas though, because sometimes the easier way doesn't work. Let me explain, all right? Because I haven't shown you anything, have I? Just blah 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 blah. So here we go. So every point, every single point, every point has an x and a y value, okay? Actually, my common core on this one is use coordinates. Okay, so it's geometry. And we're going to go GPE, and it's going to be use coordinate to prove midpoint and length. Okay, that's my common core. So we're going to talk about using coordinates to prove midpoint and length. All right, to start off, right off the bat, every single point has an x and a y value, right? Every single point's got an x and a y. So if I look at this point here, every point's got an x and a y value, right? So point C is our first point. Point D is my second point. So if it's my first point, I'm just simply going to call x1, y1. Can you guys see that way back there? First point, so that's my x1, y1. Second point, x2, y2, okay? First point, second point. So now I have to just plug them into the formula, right? The formula says x2, that's my 4, right? Plus x1, that's my -2. So my formula is going to go parentheses. I'm going to go my 4, that's my x2, plus my -2 over 2, comma, okay? So I'm just using the formula x2 plus x1 divided by 2. Now I'm going to go y2 plus y1 over 2. So we're going to go our 3 plus our -1 over 2. Okay, that's the formula. You're just going to add the x's, divide by 2, add the y's, divide by 2. I'll say it again. We're adding the x's, divide by 2, add the y's, divide by 2. Super easy. So I get a -2 over 2, and I get a 2 over 2, which is simply going to be a -1, comma 1, right? Now, I told you there was an easier way, right? Now, there is an easier way, and this is geometry. The cool thing about geometry is everything's like visual. It's pictures, right? It's figures. So the formulas work, but sometimes kids make mistakes in the formula, right? You might mess up on your negative numbers or something like that. So let me show you a super easy way to do this. Let's graph it. -2, -1. There's C. 4. 1, 2, 3, 4. 1, 2, 3. There's D. All right? Yes?
Isn't 4 plus -2, 2, not -2?
Oh my goodness, Keisha. I did make a mistake. I hate it. It's early morning. I hate it when I make mistakes. How about that? Thank you very much. Good thing I used pencil, huh? On that one. All right, so thank you, Keisha. I'm going to stop making mistakes, okay? Yeah, right. All right, let's graph CD. Now, yeah, you can see the midpoint, can't you? So the easy way is just graph it. In fact, what I want to do is just prove it, okay? We're going to prove it. So let's take a journey. Let's walk from C to D, but think about being in a city, and those are buildings, and we can only walk along the streets. So let's walk along the streets, okay? So if I walk along the streets, to get from C to D, I'm going to walk over 1, 2, 3, 4, 5, 6, right? Up 1, 2, 3, 4. So I had to walk over 6, up 4. Let's do half the journey because it's midpoint, right? So instead of going over 6, 4, let's go 1, 2, 3, 1, 2, and there's our midpoint. Isn't that easier? Much easier than the formula, right? Graph it. Find the halfway point. And we just proved it because we walked the full length, and then we took half of that full length and walked halfway. So there's a coordinate at 1, 1, not -1, 1, right, Keisha? Thank you for helping me. All right, now, distance, right? Distance is going to be the same thing, all right? So we've got these 2 points. We've got a -1, -1, that's my x1, my y1, and I've got my b, 0.2, x2, y2, okay? Here's my formula. It's a big, ugly formula, okay? So again, we're going to do it in 2 ways. We're going to do it the hard way, and there's a reason to know how to do it the hard way, okay? And I'm going to come back to that, and then I'll show you an easy way, okay? So distance, right? It is going to be, ready, big square root of, well, x2 is my 3. My x2 is my 3. Minus my x1, which is my -1. So I get a double negative. Squared. Plus, parentheses, y2, which is 2. Subtract y1, which is a -1. Okay? Squared. Keisha, how am I doing? Got them all right? Double negative, right? Make it plus. You guys agree with that? Plus, plus. Double negative, make it plus, plus, plus. So d is equal to the big square root of 4 squared plus 3 squared, right? D is equal to the square root of 16 plus 9. 16 plus 9 is 25. Square root of 25 is 5. Now they don't always turn out to be nice numbers. Oftentimes it's going to be a square root number, and we can use a calculator and get the decimal. Round to the nearest tenth, okay? Round to the nearest tenth. So if you get an ugly number, let's round to tenth, like 1 decimal to the nearest tenth. Now I said there was an easier way, right? Okay. So what is the easier way? We're going to use Pythagoras' theorem. So this is the way we will do it in here almost all the time. Okay. Negative 3, 1, 2, 3, 1, 2, 3, 4. There's x, and 2, 1, 2, 3, 4, 5. All right. Okay, if you don't learn anything today, watch this, because you're either going to have to do things the hard way or the easy way. Okay. So, I could use this big formula, okay? I could use the distance formula, and I can get the right answer. But the easier way is to create a right triangle, okay? Okay, do you see the right triangle I'm drawing? So I drew a right triangle, or I could draw a right triangle up here, but either way, do you see the right triangle I've got? So once you get a right triangle, instead of using the distance formula, let's just use Pythagoras' theorem, right? So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So instead of using this y2 minus 1 squared, blah, 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 square root, blah, 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 how about we just go as easy as this? We're going to go 9 squared plus 5 squared equals c squared. And we'll get the length of that much easier, won't we? We're going to get an 81 plus a 25 equals a c squared. Oh, let's see. 81 plus 25 is a 106 equals c squared. Or it's going to be the square root of 106 is c. Now, as a decimal, square root of 106 is about a 10.3, or approximately equal to 10.3. How's that? Okay. Now, before I stop recording, okay, before I stop recording, sometimes you need a formula, because sometimes these numbers could be decimals, right? And you'd have a hard time getting a Pythagoras theorem with decimals, right? Or sometimes the numbers might be so big that you would have to use a formula, okay? So the formula's handy. Same thing with midpoint. The formula's handy when we get really messy numbers. But if you can just graph it, if you can put the points down, draw your triangle, you can get it easily, okay? That makes sense? All right. I can stop.